All right, let's talk about writing the equation of an ellipse. So based off the information given, we just want to be able to construct that ellipse. Remember the two things that the equation gave us was the center and then the a and the b values. So we know that if we want to build the equation, those are kind of the things we need also. We need to know the center, and then we need to know the a and the b values, okay? So what we're going to do is we're going to say, okay, well, when we get to that point, we're going to have this guy over something, and we're going to have our y value squared over something, and that will be equal to 1. So that's our goal. Let's see what information it gives us. If you need to draw a little diagram, sometimes that's helpful to figure out which direction it's elongated, something like that. So on this first one, it says write the equation of an ellipse whose vertices, so we know that those are the points on the ends of the major axis, they lie at 0, 5, and 0, negative 5. So let's just draw a little ellipse here. This must be going this direction, right? Because 0, 5 would be up here, and 0, negative 5 would be way down here. So we do know that this one, and I'm going to draw a little y-axis there, is elongated this way. Now notice those are 10 units apart. So if I were to draw this right here, it looks like my center is there at 0, 0. So this one's kind of nice. We've got our center at 0, 0. And if you look at that, the major axis is 10 units long, which means my a value, which is just half of that, would be 5. So I'm going to go ahead and write a is equal to 5. Now the b value is the distance to my co-vertices, so right here. I don't know how wide my parabola is, but it did tell me that the focus, or the foci, they were at 3 and negative 3. So the question is, how can we use that to help us? Well, remember the distance from the center to the foci was the c value. So my c value down here I know is 3 units. And remember that c squared is equal to a squared, not plus, minus b squared. So we can, anytime we have two of those, the a, the c, or the b, we can find the third one. So let's just plug this in. We know that c is 3. So 3 squared is equal to a squared, which was 5, and we don't know b squared. So we've got 9, 25 minus b squared. If we subtract that 25 over, then we get negative 16 is negative b squared. So we get rid of that negative 1. If b squared is 16, that means b is equal to 4. Okay. Again, once we have the center, the a value, the b value, we can build our equation. So we could go ahead and plug the center in. There's my h, there's my k. And remember, this one's vertically elongated. So we want to take the larger value, or the a, and put it underneath the y value, because that's the vertical. That means the 4 squared gets to go under here, and 4 squared is 16. Okay, and again, we'd probably write that as x squared because we don't need those zeros there, and we'd write y squared over 25 is equal to 1. So this would be our equation. Okay. On number 8, it says write the equation for an ellipse whose major vertical axis, now that's important that we know the major axis is again vertical, and it's 10 units in length, and the minor axis is 6 units, and the center is there at 3, 1. So that's awesome. We've got our hk there. I could start even building my equation here. We just put that h on in there. Remember, we changed the signs when we put them in. Y plus 1 squared. We know that this is going to equal 1. And then we just need to find our a and our b values. Now this one said the major vertical axis, so vertical is up and down, is 10 units in length again. So if the whole thing's 10, that means that half of it is 5. So my a value in this case looks like it's going to be 5. And because it's vertical, and that's the major one, this one gets to come over here and go underneath the y, because the y value is the vertical. So 5, or 5 squared, is going to be 25. And it told us that the minor axis is 6 units. So if that's 6 units across, then half of that would give me my b value. So the b value there would be 3. And if b is 3, then 3 squared would put a 9 in my equation right there. There's my equation. All right, last one. The 4 points lie on the ellipse as vertices. So these are just giving me all the vertices together. Write the equation for this ellipse. Again, if it helps you to just draw a little graph, you can do that. Sometimes that's the most helpful in identifying which one's major and minor, or you can look at kind of the distances between them. Notice that first point says is at -2 up 2, so I could plot that point there. The next one is at 8 and up 2. So that does look pretty long. Again, notice that's 10 units long. Oh, that's really helpful, right? If that's 10 units long, then this guy must be 5. So my A again is 5. The other points there, I guess I should keep going, is at 3 and then up 4. Right there. And 3, 0. So over 3, up 0. So notice here, my minor axis, it looks like the distance to the center is 2. So my B value in this case must be 2. And we could draw our little ellipse if we wanted. Notice it's elongated horizontally. The last thing we need is the center. So either, it looks like our diagram is pretty awesome. So we can tell the center is probably sitting there at over 3, up 2. If you couldn't tell, you would just take the midpoint. I'll show you another way. So if we want to find the center, we take the midpoint of, let's say, our major axis. And you could do major or minor. You just take your x values and add them together. So -2 plus 8, find their average. The y values, find its average. And -2 plus 8 is 6, divided by 2 is 3. And the y value there, 2 plus 2 is 4. Divided by 2 is 2, so you can use that as well. Okay, then we just plug it into our equation. So here's our h and our k, which comes from the center. We go x minus 3 squared. Then we do our y value, minus 2 squared, and that's equal to 1. And again, this one's horizontally elongated, so the bigger value gets to go underneath the x this time, because x is our horizontal. So if we're looking at that, 5 squared would be 25, and 2 squared, the b value, gets to go under the other one. That would be the equation for our parabolas.